attached. Once you have two hydrogen atoms attaching to that same carbon compound, then it is a primary alkanol, where this R is an alkyl group, which is CnH2n plus 1. Then 2, secondary alkanol. Secondary alkanol is known as 2 degree. Here, the carbon atom to which this OH is attached has only one hydrogen atom. This is the carbon to which OH is attached. Is having only one hydrogen carbon. Unlike the case of primary alkanol where you have two hydrogen atoms. This one is only having one hydrogen atom, where R and R prime are alkyl group. Then you have the third one, which is tertiary alkanol. Tertiary alkanol denoted by 3 degree. Here, the carbon atom to which OH is attached has no hydrogen atom, and that can be demonstrated as this: R prime, then OH. There is no hydrogen atom attached to the carbon to which OH is attached, where R prime and R prime are alkyl group. So these are the basic difference between primary alkanol, secondary alkanol, and tertiary alkanol. Alkanols are prepared industrially from starchy food, where the byproducts are ethanol and carbon 4 oxide after undergoing series of chemical reactions and processes. Properties of alkanols, physical properties. 1. It has a colorless, volatile liquid with a characteristic taste and smell. 2. It is easily soluble in water. 3. It has a boiling point of 80 degrees centigrade. 4. It has no action on litmus paper. Chemical properties of alkanols. Alkanols have distinguished chemical properties which are very important in chemistry. 1. It undergoes combustion to give water and carbon 4 oxide. 2. It undergoes complete oxidation to give alkanoic acid as the final product. 3. It undergoes esterification to give esters and water. 4. It undergoes dehydration to give ethene. It can also give ethoxyethane in a similar fashion. This can be demonstrated. For the case of 1, the combustion formula of all organic compound is CXHY plus X plus Y over 4 O2 gas to give XCO2 plus Y over 2 H2O. The bracket can be restricted to this place to show that it affects oxygen. Oxygen outside the bracket. So for any organic compound, such as the one we are dealing with, let's take ethanol as a typical example. Here, the ethanol has, comparing now, the ethanol has C2H6O, where X is 2, your Y is 6. So the combustion formula of ethanol will be to H6O plus here you have 2 plus 6 over 4 O2 to give 2CO2 because of the X is 2 plus 6 over 2 H2O. So when this is simplified, you have this. So this is C2H6O plus, when this is simplified, you have a 7 over 2 O2 gas liquid to give 2 CO2 gas plus 3 H2O gas. So this is the combustion reaction of ethanol. Number 2, it undergoes complete oxidation to give alkanoic acid. Ethanol, under partial oxidation, it gives ethanol. It gives ethanol. This is ethanol. So partial oxidation, gives ethanol. So complete oxidation now give ethanoic acid. That's for the case of 2. Esterification and uses of alkanols. Esterification is the process by which an alkanol reacts with an alkanoic acid to give alkanoate and water. It follows a reversible reaction, and the reaction above has justified the claim. Uses of alkanols. What are the uses of alkanols? 1. Ethanol is an important solvent used to dissolve soaps, perfumes, and dyes. Likewise, the ethoxyethane is used in perfumes and dyes. 2. They are the raw materials used for the manufacture of ethanol, ethyl ester, and ethoxyethane, etc. 3. Ethanol is used as fuel either by itself or when mixed with petrol. 4. Ethanol is used as an antifreeze in automobile radiator. 5. Ethanol is present in many alcoholic beverages. Questions designed for this topic. Question number 1. Which of the following is an aromatic hydrocarbons? A. Cyclopentane. B. Toluene. C. Ethene. D. Pentanal. Question number 2. Which of the following compound exhibits resonance? A. Ethanol. B. Benzene. C. Propylene. D. Ethane. 3. Alkenes and alkyne react with the same except with a ammonium silver nitrate solution. B. Oxygen. C. Bromine water. D. Acidified potassium tetraoxomanganate 7 solution. 4. Primary alkanols are oxidized to carboxylic acids. Secondary alkanols are oxidized to alkanones, while tertiary alkanols are oxidized to A. Oxidized to alkanas, B. Oxidized to alkanoates, C. Oxidized to alkoxides, D. Not oxidized. 5. Differentiate between an alkanal and an alkanone. Answers. answers to question number 1, which says, which of the following is an aromatic compound? Aromatic compounds are generally the compounds of benzene. So, owing to the options, the only one that will fit in here, this is benzene. Aromatic. Family of benzene. The only family of benzene in the option is toluene, which has OH. Why toluene is different from benzene is that there is attachment of OH to the ring. And the answer to that question is B, which is toluene. Question number 2. Which of the following compound exhibits resonance? The only compound that can exhibit resonance is the delocalization of pi electron. What do I mean by delocalization of pi electron? That the movements of the pi electron ensure the stability of the ring. What am I talking about? When you have a benzene ring, you have pi electrons. When this one moves to this side, this one moves here, this one moves here, and the movement continues in a fascinating manner. That is what is called resonance. So therefore, a compound that exhibits this unique phenomenon is benzene, and this diagram has justified the claim. So the answer to question number 2 is benzene. Question number 3. Alkenes and alkynes react the same except with A. Ammonium silver nitrate, B. Oxygen, C. Bromine, D. Acidified KMNO4. Here, the only difference between alkenes and alkynes, even though they are both unsaturated compounds, is the reaction with ammonium silver nitrate, where alkynes is the only one that will be able to react with ammonium silver nitrate because of the bonds are at the terminal. The bonds are at the terminal. While in the case of you have terminal alkenes react with ammonium silver nitrate, but because of the fact that alkenes is double bond compounds and the terminals cannot react with ammonium silver nitrate. So the answer to the question is reaction with ammonium silver nitrate, which is A. Question number 4. Primary alkanols are oxidized to carboxylic acid. That is true. Secondary alkanols are oxidized to alkanones. That is also true. But tertiary alkanols are not oxidized. They do not have the ability to undergo oxidation. So the answer to the question number 4 is not oxidized, which is D of the option. Question number 5. Differentiate between an alkana and an alkanone. This is an alkana. Alkana with the presence of CHO as the functional group. But in the case of alkanones, this is an alkanone. The difference between an alkanone and an alkana is that this carbon, which is the functional group, attached to the single double bond oxygen. The hydrogen atom is attached to that same carbon. But in the case of an alkanone, instead of having hydrogen as the attachment to the CO bond, it is an alkyl group that is attached. Alkyl group here, but here it is hydrogen. So that is the difference between an alkana and an alkanone. In an alkana, hydrogen is attached to the C double bond O, that is the carbonyl
bond or carbonyl group. But here it is an alkyl group that is attached to that carbonyl group. That is the difference between alkanal and alkanol.